Okay. All right, so we won't get all of these done, but hopefully we can get a little ways on this. Absolute value function transformations. Whenever we were graphing those absolute values so we could solve today, what did they look like? What did those graphs look like? Show me with your hands. Like this, right? The V graph, okay? So, the V graph can be moved up, down, left, right, flipped over, stretched out, all kinds of things. And we need to learn about those transformations. So, first of all, let's just think about why it looks like it looks. If I plug in some numbers right here, then I would have, first I've got to turn my pen on. I would have absolute value of 0. That would just be 0. That means I'd graph the point 0, 0. Right? This is how any graph is made. You just plug numbers in. What about if I do absolute value of -1? What will I get? I will get +1. -1, 1. We can graph that point right there. Absolute value of +1. Nope. It's the washing machine. If you put clean clothes into the washing machine, they come out clean, right? So 1, 1 is that point. Absolute value of -2, +2. So -2, +2. That's this point right here. Absolute value of 2, 2. So we got 2, 2. Absolute value of -3, +3, -3, 3. That's this point here. And the last one will be 3, +3. That's here. And we could keep on going with this, right? We could draw our lines out here as straight as you can. Put some arrows on the end. Okay? This is what we call the parent function. Okay? So if this is like the most simple absolute value graph you could possibly have, right? It's just going to be a graph where you got the points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And then it's just sort of flipped over that y-axis. And then we have that V shape, right? So this is an important thing for you to know. If you see the graph of f of x equals absolute value of x, you should be able to graph this on a graph without me telling you anything else about it, okay? And there is a special point for this graph that has a name that we want to talk about, that turning point of the graph. So we're talking about right here, that lowest point on the graph. That is called the vertex of the graph. Okay, now what we can do is we can take this graph and we can move it however we want to move it. Up, down, left, right, flip it upside down, all those things by doing different things to our equation. Okay, so the first thing we're going to talk about is a vertical shift. Okay, this is shifting the graph up or down. In order to shift a graph up or down, any graph, not just absolute value, but we're specifically talking about absolute value here, we are going to add a number to the end of the function that shifts the graph up or down. Okay, so I've got 3 examples that are already graphed for you. The first is what we just graphed. It is the absolute value of x. It's just that V graph sitting right there with a vertex at 0, 0, right? That's the parent graph. It's like in its home position. Okay? Then, if I put a +2 on the end right here, what happens to that graph? Also, I know my scale is way too small. Those are counting by 2s. This moved the graph up 2. That's all that happened, right? So that vertex right here is now at 0, 2, right? Just shifted that graph up 2 units. So, knowing that, Uriah, what do you think it's going to do whenever we put a -1 on the end of it? Down 1. Okay, so adding or subtracting a number to the end. Notice it's on the outside of the bars, right? On the outside of the bars. That shifts the graph up or down. Okay? Questions there? Okay, we also can shift a graph left or right. Okay, so left or right is going to be by adding the number to the independent variable of a function shifts the graph left or right in the opposite direction. So I always tell students, anything on the inside of the parentheses is backwards, okay? Or in this case, on the inside of the absolute value bars. Those are acting like your parentheses here. So with up or down, it acted like you thought it should, right? +2 moved it up 2. -1 moved it down 1. Okay? When you're on the inside of the bars, everything is flipped upside down. You're going to go left or right, but you go the opposite direction. So I see right here I've got a +3 on the inside of the bars. Now, +3 is on the right side of the graph, right? Positive numbers are on the right side. But which direction has that graph been shifted? Left. So you got to go opposite direction. This is going to go left 3. Okay, so knowing that, Austin, what do you think is going to happen over here when we do a -2 on the inside of the bar? It's going to go right 2. Okay, and we can do a combination of these things. Oh, wait, I don't have a combination yet. I got one more thing we're going to talk about, and then we're going to pack up. Another thing that we have to know is that we can also flip the graph upside down. Turn our V into like an upside down V or an A without the line, okay? If you add a negative sign in front of the function, that reflects the line or the function over the x-axis. So when we put a negative out here in front of that absolute value bar, it flips that graph upside down and makes it an upside down V. Okay? Now, after your quiz tomorrow, we're going to talk about this in more detail, and you'll have an assignment that you're going to do with that. Homework tonight.